Okay, we're back. Supposedly hiccup free. We'll see. Okay. So in this next module, we're going to move on from the whole networking and storage and pieces, and we're going to start talking about a little bit about security. Some of this is things around like just concepts around security. Other pieces are just the use of IAM, which is the identity access manager, manages access to AWS resources. And then things like MFA, security, organizations, which can be used to manage multiple AWS accounts, those kind of things. So one thing to know is that Amazon wants you to be aware that they will take care of security as it relates to the core infrastructure. It's called the shared responsibility model, not a concept unique to AWS, but basically says that we'll take care of security of the cloud. You take security of what you put or do in the cloud. And the bottom line is that if you can flip a toggle switch on it or can control it in some form or fashion, the responsibility of ownership is probably going to be you. If you can log into it, it's going to be you. So if you launch a virtual machine and you can log into it, you're responsible for securing it. If you launch a database and it runs on virtual machines that you can't log into, Amazon has to secure it. If you run serverless because you can't see the servers, Amazon has to manage and defend those servers. So if you don't know where the stuff is at, then it's AWS's responsibility. If you don't have access or control over it, it's AWS's responsibility. So for example, operating systems, host-based firewalls, managing your account, setting up your security groups, you have control over all that. So that's the customer, that's us. But you don't know where their data centers are. You don't control the physical host. You don't control the network. You don't control any of the hardware and software infrastructure. So AWS has to take care of all that. That's all them. Now, with those concepts in mind, let's ask some quick questions here. Who's responsible for configuring your firewalls on your EC2 instances? Is that AWS or is that us as the customer? That's going to be the customer. Good. In terms of maintaining network infrastructure, is that going to be us as the customer or is that going to be AWS? That's going to be AWS, right? Good. In terms of locking down the physical data center, who's responsible for that? The customer or AWS? Well, if Michael wouldn't click the thing too early, we could all have a question there. But unfortunately, it's AWS. Right? Customer didn't have a data center. So you're absolutely right, Kazim. So then who's responsible for patching software on EC2 instances, right, that you launch? You or AWS? Customer, right? You launch it, you own it. If you can log into it. If you can't log into it, then you're not responsible for it. So this is the customer because we can launch EC2 instances, right? Yeah, as long as it's running. I think that's Kazim. I think you're right. Who's responsible for maintaining the physical hardware that runs the Amazon EC2 instances? Is that AWS or is that the customer? So who's responsible for I'm just going to make this up because this is not what they use, but who's responsible for patching VMware if they were using VMware as their hypervisor? Yeah, that would be AWS, right? They don't use it. They don't use VMware, by the way. I mean, don't get me wrong. They have VMware available for use, but mainly they use a variant of Xen, XEN, sorry. But it's so far from the main branch of Xen that it might as well just be its own flavor of virtualization. Who's responsible for setting permissions on Amazon S3 objects? Who needs to set the permissions on your S3 buckets? You or AWS? Customer or AWS? Good. Customer. Good. All right. So that gives you an idea of the shared responsibility model. Amazon handles its pieces. You handle your pieces. If you come to an audit, by the way, Amazon's a great partner. I've been set through several audits with AWS. And most auditors are familiar about how to navigate with them. So it's really clear lines there. All right, so let's talk a little bit about how you control access to your AWS resources. So in our coffee shop, if someone wants to get logged into the cashier interface, they have to get a login. And they might get access to the cashier interface, but not access to the inventory management space. This is where this service called IAM, Identity Access Management, comes in. This service has three principles: users, groups, and roles. Policies are attached to either the users, the groups, or the roles. Policies grant or deny permissions. Now, before we can even get into IAM, though, someone's got to create the AWS account. That's called the root user. So when you create an account, you use an email address. That email address is the root user, the owner of that account. Every account must have a unique email address. So the minute you create your first account, by the way, it's recommended that you create an IAM user, give it permissions to create other users, and then put the root user away. Do not use the root user to log in, because if it gets hacked, there's no restricting what that user can do. So instead, just log in as your newly created IAM user and create everything you need. Now, once you've created an IAM user, then you're in IAM like space. And IAM users are like inside the account. So this is typically an identity that can interact with AWS services. Think of IAM users as permanent credentialing. So this could be a user, it could even be a service in some cases. And these users are going to get policies attached to them. These policies are going to grant or deny access to AWS. Here's an example policy. Notice that even without ever having seen this before, you probably can tell by looking that, one, this is going to allow something to happen. It's going to be about S3, even if you don't know what list object and get object are. And notice that it lists a very specific bucket and the contents of that bucket. So even though you probably have never seen this before, you can kind of figure out what's going on. Now, most of the time, you're not going to attach policies to users. You're going to attach policies to groups and then put the users inside groups. That way, the group can have a name like read-only access to project A, or read-only access to project A's S3 bucket, or or full read-write to project A's, S3 bucket. It doesn't, like, usually that's what they do, is it, like, the name of the group intuitively reveals what the permissions are. But it's really just a collection of users. Now, we talked about users, groups, and now we're going to talk about roles. Now, roles are interesting because basically a role is a security identity that a user or another service, AWS service, can assume. It can become that role to get temporary elevated permissions. This works no differently than how Windows does that administrative challenge. It's like, do you want to run this as an administrator? Or if you're on Linux and you want to run sudo, depending on how you pronounce it. This gives you temporary elevated permissions. So the owner is going to give the employee permissions to switch to specific roles. In this case, right, you might give the new employee the permission to switch to the cashier role, and the cashier role has permissions to do things. I'm going to give you an example of this. You can see it in action. As you can see in the upper right-hand side, I am currently logged in as Spartan Sage M. Forrester. But let's say I want to go make some changes to my account but I don't have permissions as Spartan Sage. What I can do is I can say, look, I want to switch roles. So what I'm going to do is I'm going to give myself some elevated permissions. But before I do that, I need to make sure I have my account number, which I didn't. I'm going to do that now. Now I'm going to switch roles. So here's my account number. And now what's happened is look in the upper right-hand side. I've now elevated my permissions to admin. Now let's be clear. That role had to say that I, Spartan Sage, could assume the role. Not just anybody could assume the role. I have to say that that role, it can only be assumed by these people or the entire organization. It just depends on how you want to restrict it. But notice that I am now a different set of security permissions. That's what a role is. A role is a different set of security permissions that you can assume as a user. You can, by the way, assign a role to EC2 instances. You can assign a role to a Lambda function. You can assign a role to a container. You can assign a role to a bunch of different services in AWS. So that's all a role is a role is just a set of permissions that you can assume. And you can literally just assume the role that you need at the time that you need it. So again, users, groups, and roles. Roles are assumable. You can change your identity a little bit and become the role. Now, switching over just a little bit, just know that when you have a user and you want to log into the console or log into other, like the command line, you can actually add two-factor authentication. This can be based on, a hardware key. It can be based on Google Authenticator. It can be based on AWS's Authenticator. It can be based on whatever authenticator supports it. So the user will be authenticated once they can tell you the password, right? Or, and they can provide something that they have in their possession. Okay. So remember, IAM is comprised of three principles: users, groups, and roles. Policies can be assigned to any of those, but typically policies either assigned to roles or groups. And remember, roles are just a temporary set of permissions that someone can assume. Users are permanent permissions. All right, let's talk about organizations. So IAM is on a per account basis. What if you have to manage multiple accounts? Well, this is where organizations comes in. Organizations helps you, like basically large enterprises, manage multiple accounts, right? Because things could get pretty intense pretty quickly. In other words, when I walked into Honeywell back in 2018, they had 700 AWS accounts. Without organizations, there was going to be no way to manage that. So organizations was absolutely essential to make sure that they can manage that many accounts, because there were 700 of them. Otherwise, that wasn't going to happen. So organizations, think of it as a meta organizer for a bunch of AWS accounts. And that's the kind of thing you want, right? Is that you want to be able to have a service that can manage all these other like account services. By the way, this is by invitation only. So just because you get invaded, it's not like you're forced to be part of an organization. You could like accept the invitation, not accept the invitation, as you see fit. So the great thing about this also is that this will allow you to centralize things like service control policies, auditing, logging, billing can get consolidated as well. And you can actually organize accounts into what they call organizational units, kind of similar to the way Active Directory does it. So you can actually create like a root OU, or you could create a prod organizational unit, or a dev organizational unit, or a product A organizational unit, or, this is the connected plant. This is the digital airplane division. This is the quantum computing division. You could do that as well. Notice here that legal and HR are part of a different organizational unit than, say, finance and IT. Okay, so here's a little knowledge check. A customer is configuring service control policies in AWS organizations because they want to be able to put some limits on multiple accounts. Which identities and resources can you apply service control policies to? In other words, which of these two items here are actually part of running an organization and not part of IAM? That's what they're really asking. Good. So let's just say this is that users, groups, and roles belong to IAM. They don't belong to organizations. So by exclusion, you can actually do an individual member account or you can do an organizational unit for SCPs, but you can't use IAM policies. So here's the interesting thing about service control policies. You can limit someone's ability to run a service, but that doesn't grant them access to the service. Oddly enough, you still have to log in to each individual account and grant them access to the service, but you can deny it at the organizational level. Really strange. Not sure exactly what Amazon's thinking was there, but it was weird. All right. So let's talk about a little bit about compliance. So do note that inside every single AWS account, there is a service called AWS Artifact. Not the greatest name, because this service actually doesn't do anything, provide you all of AWS's attestations around security. That's all it does. You can literally go in and download every single compliance report they have. Just so you can see this in action. So if you want to, if you're looking for PCI compliance, or you can find the attestations and the certifications. So just know also that inside here, if you have any agreements with AWS, like you have like a enterprise agreement or some other kind of contract, it'll actually show up here as well. Notice if there's a data breach or whatnot, there's all listed here. I don't think there's any organizational agreements. That's where you would find, by the way, any contracts. Oh, look at this. So Artifact is available in every single account. Most of them have the same thing in them. Now, this is a list of Amazon's, certifications, both European, global, Asian Pacific, North American. Just because, by the way, they say they have HIPAA compliance doesn't mean that every service is HIPAA compliant. So make sure you read the fine print as far as which services can be made to be HIPAA compliant versus other services. Other thing is know is that if you go to the AWS Customer Compliance Center, you'll find a lot of information. If you need to get white papers or access to documentation, auditing checklists, code of conducts, right? Just know that there's a lot of stuff out here under the Compliance Center. Okay. All right, knowledge check. Which two tasks can you complete inside of AWS, the service AWS Artifact? Okay. See, Grace, you said access AWS compliance reports on demand and then review and manage agreements. And that's exactly right. That's exactly what Artifact is for, is that how do I look at all the compliance reports and do I have agreements with AWS that I need to like sign and be aware of? They're right there. Good. All right, in terms of compliance then, what about AppSec? What if we need, for example, to protect against cross-site scripting and SQL injection attacks? What if we need to, do some filtering because some guy in Colorado has decided that our website's really interesting and he keeps trying to penetrate it, like hack it. It's like, eh. So the answer for this, and this is where they start putting acronyms up and they don't explain what they are. This is the web application firewall, right? Which is an industry standard term. It's not something AWS came up with. WAF is a pretty standard kind of common use, like networking filter. And it works based on rules, right? You use rules to say this traffic is either allowed or this traffic is denied or some combination of both. And it basically tries to identify like badly formed or malicious traffic. So if there's a malicious request that comes in, the WAF would be like, nah, can't really come in. It's really built to, kind of like stop those malicious intentful attacks. But if you have denial of service attacks or distributed denial of service attacks, and it might look like legitimate traffic, what you're going to have to do then is you're going to have to use AWS Shield. But here's the cool thing. AWS Shield is enabled for all accounts by default. So Amazon is constantly mitigating attacks against your infrastructure and their infrastructure. But you can pay for a more advanced version. It's called Shield Advanced. If I remember correctly, I think it takes like a year commitment, costs about $18,000. You get access to a dedicated security team, not a dedicated, I'm sorry, a shared security team, not dedicated. Not sure what I was thinking. You, by the way, can integrate Shield with WAF to write custom rules that'll mitigate complex denial of service attacks. Now, if you need to do penetration testing because you'll need vulnerability assessment, Amazon Inspector is really good at this. Amazon Inspector is going to attack virtual machines. I'm not attack. That's not what I meant to say. It's going to assess virtual machines from the networking perspective and from the operating system perspective, but only if you run an agent on your systems. So Inspector is going to just do an automated security assessment. It does check against known CVEs that are published. And so it'll like publish the results of those findings and then share it out with everybody so you can see it. So remember, WAF is a web application firewall. Its job is to stop like SQL injection, cross-site scripting, so malicious traffic. Shield is activated by default on all accounts. Its job is to stop distributed denial of service attacks. And Inspector is a vulnerability assessment tool for EC2 instances. Amazon has a bunch of other security services. There's the key management service, which does symmetric and asymmetric keys. There's Guard Duty, which uses machine learning to look for probes and recons against your VPC traffic. There's Detective, there's the Resource Manager, there's the security. Oh God, I can't even remember the names of everything. There's a bunch of security services. So Amazon maintains a lot. If we go out and look actually on the console home for just a second, and we scroll down under all services just for security, Guard Duty is the network manager that's going to look for malicious network traffic. The Inspector was the one we just talked about that actually does kind of vulnerability assessment. Macy checks for PII, personally identifiable information inside your S3 buckets. The key management service we just talked about. WAF and Shield, right, is there to kind of stop malicious injection of traffic. Artifact Security Hub, Detective, there's the network firewall, which is another firewall. So if you want to add another firewall into your system, you can. There's also a signer and an audit manager and a bunch of other pieces. And some of this is actually in other sections as far as some of the security piece. But I think I said this before, it's that almost every design decision that you make inside of AWS, every toggle usually has a cost implication as well and or a security implication, if not both. So just keep that in mind. All right, here's a quick knowledge check. What is an IAM policy? What does a policy actually do? It is associated with permissions, right? But it's not an identity, right? So we know it's not C or D. And the first one sounds like multi-factor, two-factor, right? So B is probably the answer. A document that grants or denies permissions to AWS services. That is definitely an IAM policy. All right, if someone requires temporary access to create several buckets, there's one of the IAM principles that is perfect for temporary access. What is it? Yeah, IAM role. Perfect. Yep, that's correct. Definitely not going to be the root user because that's like an Uber power user that nobody should be using. A group is, an appropriate if you want to get them like permanent access. Service control policy actually denies access. So, yeah. So 3 is definitely the answer. C. Okay. Which of these describes the concept of using least privilege when it comes to granting permissions to users? Good. Granting the permissions that only the permissions that are needed to perform the specific task. That is exactly dead on. Good job. Which service helps protect your applications against distributed denial of service attacks? It's on by default with every account. Good. Yeah, Shield. Right, Shield is on by default. And remember, there's an advanced version. Pay some money, get access to a shared account, get proactive, get access to the API. There's a bunch of stuff, enhancements that come with Shield Advanced. But yeah, Shield comes with every single account. Good. All right. What can the AWS key management system before? What is its job? And when I said symmetric and asymmetric keys before, what was I talking about? Well, what I was saying is that symmetric and asymmetric keys are forms of cryptographic keys. So that's what the key management system is for, is its job is to create, delete, manage, refresh, associate different cryptographic keys. Excellent. All right, in this module, our focus was just about security. The shared responsibility model, IAM, understanding like a little bit about the 3 principles and the policies that get approached there. Understanding a little bit about the compliance possibilities inside of AWS, including what Artifact does, Inspector does, Shield, WAF, that kind of thing. Okay. Any questions around anything around security thus far? Any curiosities, soliloquies, anything that kind of pops into your brain? Okay. All right. Bear with me one second.